In this video, we'll talk about logarithms of base 10. So a logarithm that is base 10 is actually called a common logarithm. And there are many uses for logarithms base 10. For example, the Richter scale, a scale that measures the magnitude of earthquakes, the pH of water, which it measures the alkalinity, and decibels in sound. So the value that you hear about, for example, when someone talks about an earthquake that measures a 6 on the Richter scale, that 6 is actually the exponent on 10. And so an earthquake that measures a 7 then is 10 times stronger than an earthquake that measures a 6. So those values, the 6 and the 7, are actually the exponents on 10, and another word for an exponent then is a logarithm. So these are logarithmic based scales. And specifically, logarithms base 10 are very common. And so often you'll see that the base 10 is actually left out. And so we just write log and not log base 10. Log base 10 is not incorrect, but when you don't see a base, you want to then assume that the base is a 10. So your scientific calculator is programmed for common logarithms, which are log base 10. So have a look at your calculator now and find the log button. Remember to only use it for base 10 logarithms. And actually, you can go ahead and try some of these on your calculator. I will actually write in the values as we do them. So if with your calculator, find the log of 1,000. And that's a 3. And that's because 10 to the power of 3 equals 1,000. So what is the log of 10? We're asking ourselves what exponent, because this represents an exponent, just the way the 3 did. The exponent on 10 to equal 10. And this will be a 1. And you'll see, if you punch into your calculator log 10, you will get a 1. Now, log 75 will be somewhere between, what do you think? If log 10 is 1 and log 100 is 2, then it's somewhere between 1 and 2. So type in log 75 and you'll see 1.875. There are more decimal places there, but I'll write it down to those 3. And log 6, 0.778. And there are more decimal places for that as well. We'll just write them down that far. Just keep in mind, if you are going to use these values for future calculations, that log 6 is much more precise. Because log 6, if you look at your calculator, is 0.77815125, and more if you have more digits on your display. So if you make a calculation with it and you round it here, you are affecting your future calculations. Now, there is something called a common anti-logarithm. And this is the value of 10 raised to a logarithm. So take a look at that log button on your calculator, and you'll notice that the second function of the log button says 10 to the x. So you see on your log button here, but above it, it says 10 to the x. When you raise 10 to a power, you are actually finding a common anti-logarithm. It's common because it's base 10, And it's an anti-logarithm because you're raising 10 to an exponent. So, find the common anti-logarithm of the following values. We are using the second function key, which means we have to punch into the calculator second function log, or shift log, whatever it looks like on yours. And you will enter in a 3 and press equals. You'll see that it is 10,000, or 1,000, sorry. Since 10 to the power of 3 equals 1,000. Next, try the 5. So you're raising 10 to the power 5 using that anti-log key. 100,000. That's 10 times 10 times 10 times 10 times 10. How about the common anti-logarithm of 1.2? And you should see 15.8489. And it does go further. I will stop it there. And the common anti-logarithm of 0.6. 3.981. We'll stop it there. Okay, this means we have taken 10, raised it to the power of 0.6. And so on. All right, so that's our video on common logarithms and common anti-logarithms using the log and the 10 to the x key. Thank you.